Hello student, today we are going to learn comparison of linear motion and rotation motion. Okay, in linear motion displacement we can call as a s, in rotation motion displacement we can call as a theta, angular displacement. Okay, velocity we can call as a v, angular velocity we can call as a omega. Okay, then acceleration we can call linear motion a, in rotation motion acceleration we can call as a alpha. Okay, here linear motion initial velocity you can call as u, v is the final velocity, u is the initial velocity. Okay, now here angular rotation motion omega naught we can call as initial velocity. Okay, now we will see each and everything like this comparison, term wise comparison with the definition, unit, everything I am going to teach you. Okay, the first comparison, see here, it is linear motion, s is going to be the displacement. Okay, the unit of s is meter, dimensional formula m power 0, l power 1, t power 0. Okay, in linear motion. In rotation motion theta, what is the unit of theta? Whether it is a degree or we can take it as a radian. Okay, we can take it as a radian. So dimensional formula, there is no dimension formula, m power 0, l power 0, t power 0. Okay, next one, velocity. Velocity is equal to displacement by time. What is the displacement here? Displacement unit is a meter, time unit is a second. Okay, in rotation motion omega we can take it as angular velocity, angular displacement by time. What is the angular displacement unit? We can take it as a radian. So radian per unit second, time period is a second. Okay, the next thing, so what is the dimensional formula? So we are doing with the comparison of linear motion and rotation motion. Okay, so this side dimensional formula, m power 0, l power 1, t if you are taken second, we are taken denominator to numerator, t second minus 1, t minus 1. Here dimensional formula, m power 0, there is no mass, length power, length is also not there, time is there, t power minus 1, because the unit we can take it as a radian second minus 1. Okay, next angular acceleration. Linear acceleration is called linear velocity divided by time period. Okay, same angular acceleration, angular velocity by time period, angular velocity by time period. Okay, so the unit of this velocity is meter per second by second, so meter by second square unit. So otherwise meter second minus 2 also we can take it. What is the dimensional formula? M power 0, L power 1, T power minus 2. Again angular velocity. What is the dimensional formula? Omega is rad per second. Time is second. Okay, second square, radian by second square. From denominator if you are taken numerator, radian second minus 2 will be there. What is the dimensional formula? M power 0, L power 0, t power minus 2. The another form of angular acceleration, just to see here, linear acceleration. Acceleration is equal to rate of change of velocity. Velocity is equal to rate of change of displacement. You can write like this, ds by dt. So whole equation we can have acceleration is equal to ds by dt. So double time differentiation also will give. Okay, same like alpha also you can write d square by dt. Here theta like that you can write, two time differentiation, other form of equation for the alpha. Okay, next here in linear motion we can call as a p is the momentum. Here p is called momentum. Momentum is equal to mass into velocity. In rotation motion L is called momentum, linear angular momentum. Okay, linear momentum into radius which we are taken as the angular momentum. Okay, here product of mass into velocity. Okay, mass is kg, velocity is meter by second, so kg meter second minus 1, which is called linear momentum. Dimensional formula m power 1, l power 1, t power minus 1. For angular momentum, linear momentum into radius, kg meter second minus 1 into meter. What is meter? Meter square. So kg meter square second minus 1. So what is the dimensional formula? M power 1, L power 2, T power minus 1. Okay, in the next one. Okay, In linear motion, mass we can take it as a m. Okay, mass we can take it as a m. Mass only. Okay, the unit of this is kg. What about dimension formula? M power 1. Length is not there, time is not there. Okay, but in rotation motion, mass is going to be a inertia, moment of inertia, mass into radius square. Okay, it's depend on the radius. Okay, kg meter square is the unit. What about the dimension formula? M power 1, L power 2, T power 0. Okay, this side is linear motion, this side is rotational motion. Okay, next comparison. So now we are going to learn the relation, then I will come with the comparison. Okay, because you required this relation. Okay, so it is a relation. So we have circle. Okay, we have circle. The radius of the circle I am taken as a r. The angle of the circle theta. Arc length I am taken as a s. Okay, so now what is the relation between theta, s, r? So theta is equal to s by r. Okay, s by r. So theta is the angular displacement, r is a radius, s is a linear displacement, arc length, s is the arc length. So s is equal to theta times of r. Okay, if you want proof for full complete circle, arc length is going to be 2 pi r by r get cancelled, 2 pi is 360 degree for full complete rotation. Okay, now I have this is a equation. Okay, this equation is correct only for if you want to verify that equation, then only you can go that. Okay, differentiation of this with the equation with respect to the time, above equation with respect to the time, ds by dt is equal to d theta by dt into r. Okay, into r. It is called velocity is equal to omega into r. Linear velocity is equal to angular velocity into radius. Okay, again I am differentiating this equation. Again, if you are differentiating, what I can get? See here, dv by dt is equal to d omega by dt into r, radius of the circle. Okay, this is which is going to be called velocity by time, angular velocity by time. Okay, a is equal to alpha r. A is equal to alpha times of r. Okay, it's a very important relation. Okay, finally we concluded relation between linear motion and rotation motion. Okay, this side is linear motion, this side is rotation motion. Okay, if you want common relation, s is equal to theta times of r. Okay, v is equal to omega times of r. Okay, a is equal to alpha times of r. That is a common relation we discussed. Okay, next, this side I am taken as a force. F is equal to force. Force is equal to mass into acceleration. Okay, so force is equal to mass into acceleration. Mass unit is kg, acceleration unit is a meter per second square. So dimension formula m power 1, L power 1, T power minus 2. Okay, same unit if you want in rotation motion, torque. Torque is equal to force into perpendicular distance. Okay, perpendicular distance. Okay, if you want unit, Newton meter. Okay, Newton kg meter second minus 2. It's called force unit only into meter. So kg meter square second minus 2. Okay, so now torque relation. Okay, torque we are learning. Torque is equal to, in rotation motion, torque is equal to force into perpendicular displacement. Okay, that's going to be kg meter square second minus 2. If you want dimension formula, m power 1, L power 2, T power minus 2. I got torque dimensional formula. Okay, you can give the torque another formula. Torque is equal to I alpha also you can give. How I got I alpha? Torque is equal to force into perpendicular distance, mass into acceleration into perpendicular distance, radius. A is equal to alpha times of r. A is equal to alpha times of r. Torque is equal to m alpha r into r, mr square. So mr square alpha will get as the torque is equal to I alpha. Okay, so equivalent torque unit we can take it as a force here. Force is equal to mass into acceleration, which already we know. Okay, next, angular momentum. Okay, angular momentum L is equal to linear momentum times of radius. Okay, linear momentum mass into velocity into radius. Okay, velocity v is equal to omega times of r. If you substitute this, m omega into r, so mr square omega. So angular momentum is equal to inertia times of omega. This also one of the relation. Okay, in rotation motion. Okay, so just we are comparing with linear motion and rotation motion. Okay, next what we are going to do, energy. Okay, this side is energy. Work done is equal to force into displacement. Work done is equal to force into displacement. In rotation motion, work done is equal to force, we know torque, displacement is angular displacement, torque into d theta. Okay, this side see here, force into displacement, force into displacement, Fs, work done is equal to Fs. Okay, here work done is equal to torque times of theta, work done is equal to torque times of theta. Okay, now same thing, what is the power here? Power is work done by time. So power is equal to force into displacement by time period, we can have the velocity. So power is equal to force into velocity. Okay, same equivalent unit what we can get in a rotation motion. So power is equal to work done by time, what is work done? Torque into theta by t, will have omega, so torque times of omega, so that's called power. Same, force is torque, the initial velocity is omega. Okay, so this side is linear motion, this side is rotation motion. Okay, next, equation of motion comparison. So see here, this side will be equation of motion, so this side will be equation of motion. V is equal to u plus at, S is equal to ut plus of at square, v square is equal to u square plus 2as. Okay, same equation comparison in linear motion. Okay, what, or in rotation motion, v is equal to omega, so omega, v is omega, I'll write here symbol, v is omega, u is omega naught, s is theta here, a is alpha here, t will be for time period, time will be same with both the place. Okay, so omega is equal to omega naught plus alpha t. So second equation, theta is equal to omega naught t plus of alpha t square. Okay, the next one, omega square is equal to omega naught square plus 2 alpha theta. Okay, just a comparison with equation of motion. Okay, next, kinetic energy relation. This side, what is the kinetic energy? No, of mv square. Kinetic energy is equal to of mv square. Okay, what about this side, kinetic energy, rotation motion kinetic energy? Rotation motion kinetic energy is equal to of times of mass, we can take it as a inertia, velocity we can take it as a omega square, I omega square, we can take it as a energy, kinetic energy. Okay, so I will repeat again, kinetic energy is equal to of mv square. No, we know omega times of r, if you substituted here of times of m omega square r square omega mr square will be inertia of I omega square. This is the kinetic energy in rotation motion. Okay, if you learned these are the formulas, the maximum part of the rotation motion will get over. Thank you for watching my channel. If you like my channel, please subscribe. Thank you everyone.